Welcome back to another Beyond Clean Expert Series. You're watching the Chemical Monitoring Expert Series with our chemical monitoring expert, Alex Hilliker. I'm your host, Bobby Parker. And on today's episode, we are taking a step from the technical and theoretical world of chemical monitoring into the real world. Alex, I'd like to take us on a tour through some departments. I know that you get the benefit of working with real people in the real world about chemical monitoring, and would love to hear your experience and perspective with departments that are implementing this kind of technology.
Yeah, thanks, Bobby. We're happy to be at this point in the series where we can talk about the real world, how this is happening in departments across the United States, but also around the globe as well. And what we've done is we've pulled together 3 examples for this episode, one for each of the chemicals that we've been talking about throughout this series. Ethylene oxide, of course, hydrogen peroxide, and parasitic acid. We're going to start with ethylene oxide, which is, I think some people were surprised in our earlier episodes to learn that it's still being used out there. In fact, there's a large hospital that's affiliated with the University of Minnesota that we talked to that's still using ETO on a regular basis. And they recently upgraded their continuous monitoring system for ethylene oxide because they wanted to be focused on that safe and compliant workspace. That was a top priority because of ETO's health concerns. It's a carcinogen, which is well documented. And they had an older system in place that was more like a leak detector, for example. It's going to give you a warning in the event of a catastrophic failure or a leak of ETO into the department. But they wanted better visibility, real-time readings, continuous monitoring at those lower levels, that 1 part per million occupational exposure limit that we've talked about in this series. They also wanted increased visibility across the department to improve workflows, because if you can see an imperceptible gas through a continuous gas monitor, you understand when you can interact with that particular product and when you need to avoid it to mitigate that overexposure.
Right. Yeah, that makes sense. I think folks who think about ETO, they picture in their mind like this ante room and this really big ethylene oxide sterilizer, and they think, unless there's an environmental monitoring in place, like I'm not going in there, and like that, and that's right and good, right? We've had for a very long time had a requirement in place for environmental monitoring, but it sounds like what you're telling me, Alex, is there's levels to this. Just because you have an environmental monitor in place doesn't necessarily mean that you've nailed down the peace of mind piece and the data logging piece.
Oh, no doubt, Bobby, and I think this particular hospital is also a great example because they are going above and beyond. They're monitoring their storage cabinets where the ETO canisters are housed. And they're also monitoring their abater systems in the event of a failure of that system. So they're really checking all the boxes to keep their team members safe from that exposure opportunity to ETO throughout their entire department.
Yeah, nice. Well, one of the areas that we've spent the most time talking about, Alex, for chemical monitoring, and it's one that has me most curious, is chemical monitoring for hydrogen peroxide sterilizers. I say that because back when I was leading a sterile processing department, it didn't seem like it was all that common to be monitoring hydrogen peroxide in the department, and a lot of conversations going on around that. What are you seeing for departments that are starting to implement monitoring for hydrogen peroxide sterilizers?
Yeah, hydrogen peroxide is something that has been monitored for a long time, but it is becoming more commonplace, as you noted, Bobby. And so for this example, there's a VA medical center in South Carolina, and they've been monitoring for hydrogen peroxide for nearly 15 years now, since kind of 2012 timeframe. And what's interesting about this particular case is some people may be surprised to know that VAs are actually leading the way in terms of chemical vapor monitoring in a lot of ways. The vast majority of VA medical centers around the country are monitoring for hydrogen peroxide and parasitic acid. And so this particular hospital in South Carolina, they understood that it wasn't just about the 8-hour time-weighted average or the permissible exposure limit over the course of their shift. They understand it's also about the acute exposure events, those peak emissions that can occur during routine events like opening the sterilizer door, for example. And we've talked in this series and CE courses and other events that we've done together, Bobby, about documented studies that show that sometimes those levels when you open a door can be 20 parts per million or more, which is far above generally considered safe levels. And this particular hospital realized that if you don't have a sensor and a monitor on top of each machine, you're flying blind and you don't know what those levels are because H2O2 is odorless under those particular levels.
Right. It makes me wonder, for a department that goes from not having monitoring to monitoring, do they ever get surprised whenever they see those numbers for the first time? Like, what I mean is, when we recommend a borescope, say for a department, so that they can look inside lumens of devices, that first week that they get the borescope in the department, a lot of stuff going out for repair, right? Because you've never seen inside there before, right? You just don't know. Is it kind of the same thing for chemical monitoring sometimes?
It can be, yes, Bobby. I like to say when you shine a light on something, you're going to see it. Fortunately for this hospital, they noted when we talked to them that alarms and alerts are actually quite rare, which is a good thing. That's what we want. You don't want your smoke detector in your house going off all the time, of course. But they stress this peace of mind and this confidence that their staff has interacting with their low temperature sterilizers because of that reassurance of the monitor telling them in real time what those concentrations of hydrogen peroxide are in the area.
Yeah. Yeah. I want to make sure that we circle back one more time to something you said at the beginning when I asked for real world stories. You said around the globe. Any stories from across the pond or what's going on in other countries as well?
Yeah, it's interesting, Bobby, because we talk a lot about what's going on in the U.S., but I think it's good to broaden our focus as well to countries like the United Kingdom, and the National Health Service in the U.K. They have a body called the Joint Advisory Group on Gastrointestinal Endoscopy. Nailed it that time. That's a hard one to say.
Got it.
Having a continuous PAA monitor is a best practice requirement according to that JAG organization. And so this particular hospital that we were working with, this was a recommendation in an audit that they had. It was an audit finding, and so they identified that during the chemical changes for their AERs, their automated endoscope reprocessors, that was a higher risk event of their team members being overexposed acutely to parasitic acid. So they wanted to put that real-time monitoring capability in place so that they could track those short and long-term exposure levels to keep their team members protected and to mitigate that particular exposure event. And I think it's important to say that their SPD leadership noted that PAA was for a long time considered to be sort of less dangerous in quotes than other chemicals. Glutaraldehyde was what PAA largely replaced as a high-level disinfectant, and glutaraldehyde is now banned in the United Kingdom. And people are realizing, just like this hospital realized, that overexposure to parasitic acid can be dangerous in its own right, and it's important to monitor on that continuous and real-time basis.
Yeah. One of the common themes that has come up through each of these stories in my mind has to do with compliance, right? Because the facility that you mentioned for ETO, even though they had a monitoring system in place, like they wanted to do something better, but the old one that they had was compliant with the requirement for environmental monitoring, or at least that's what it sounds like. And at least here in the States, there's not a requirement for monitoring hydrogen peroxide or peracetic acid, at least yet. And so it's interesting to see that like this shift in the industry is largely being driven by a desire to do the right thing and kind of use some common sense about protecting our employees, and not necessarily a regulatory push.
Yeah, you're exactly right, Bobby. It's all about the peace of mind, but also the culture of safety in the department. And continuous monitoring is one way among many to instill that across your team.
Well, that's going to do it for today's episode. Thanks for walking us through those, Alex. If you have any further questions around chemical monitoring, I'd encourage you to reach out to Alex directly. We'll be back with you next month, continuing this continuous monitoring series. But until we talk to you again next time, keep fighting dirty.